Hey, this is Nick Weber with Anabranch Solutions, and thanks for joining me for what will be a short discussion on field design documentation and approaches for data capture and management of low-tech process-based restoration projects. Um, as far as a chapter to reference within the design manual, I would say the information that I'm going to cover today really draws from each chapter, whether it's design, planning, structure specifications. It's really kind of highly related to really the bulk of the information. Okay, so we've seen a lot in this workshop, and hopefully by now you are feeling like, LTPBR planning, design, and monitoring. There's really nothing to it, but you need to know how to do and be familiar with all these things, right? How are you going to capture data in the field, some stream surveys, manage your projects and organize your projects for 10 years, all these things. So ideally you think there's really nothing to it. Well, that's probably not entirely true. And so we, as a group, your instructors and our colleagues have begun working on kind of an operationalization of the LTPBR approach. And this so far has been dubbed the Project Implementation and Monitoring Protocol. And its goal is to kind of offer a unified framework for managing LTPBR information, both handling things like data capture, data management, some amount of metric calculation and summarization, and then sharing and disseminating information. So that is a lot of what I am going to introduce to you today, is some of the aspects of this protocol. Okay, so yeah, short outline. I'm going to talk about, hopefully convinced you a need for a unified framework, give you an overview, talk about the data management solution, a little bit about things like design and implementation components, monitoring components, and then some protocol resources. Okay, so let's move into the overview. So this table just summarizes the primary protocol components, really broken into things like design and implementation, a set of monitoring survey protocols, and then a data collection and management solution. We also talk about their function application and kind of target users. I'm going to go into all this. This is really an outline for my presentation here eventually. So let's first take a look at and talk about the current data collection and management platform. It's currently a FileMaker database. I'm just going to briefly touch on a little bit of features. So this database can be run on desktops, on Windows and Macs. In the field, you can use an iPad for data capture. Offers a bunch of features like mapping and GPS, photo capture and storage, and exports in a number of different formats like CSVs and PDF reports. So that's really just a little taste of the features. This is just a screenshot of the interface. But let's just, because we can, very quickly take a brief look at the database. Opens to almost a dashboard of projects. We can enter a project, and we start to see things we should be getting familiar with as a part of this workshop. Reaches, complexes, floodplain widths, objectives, so things like that. So taking all of these different components of our LTPBR projects and storing them in kind of a unified framework. I mentioned there is some amount of mapping. I'll just show you that. We can show things like our reach starts and stops, our structures. We can toggle things on and off like complexes and photos, but so some amount of mapping right into your database. A nice feature. We also can mark things in the field. This won't work on a desktop, but if I was on a mobile device, I can GPS complexes, structures, and locations of all the different components of my project. We can do things like capture repeat photos. So this is just a repeat photo stream starting in, this one starts in August 2017, showing a BDA being built and spans up to, wow, goes through June 2020, where it's just a green oasis. Pretty neat. So great resource for capturing repeat photos. And I wanted to just quickly demo, we can do a number of exports. So there's these PDF exports. I will just very quickly show you. So this is an example of a project level export with my project characteristics, things like structure types, total structures, my reaches and their attributes, again, structure types, implementation phases, and when they occurred. So kind of our custom reporting, just an example. And this is just an example of, say, an Excel spreadsheet of the locations of all of my structures, their structure type, where they are, what they're doing, and things like that. So very nice. All the data that goes in is very accessible to you and comes right back out. Okay, so that's just a short piece of an introduction to the data management platform. Next, I want to talk a little bit about how the protocol actually kind of handles design and implementation. So as we saw, it's the database is set up, and the protocol hits a lot of the different kind of planning and design components that we've heard about already in the workshop. Spatial design components such as reaches, their attributes and objectives, complexes and structures, temporal organization of multi-phase projects and pilot implementation pieces, as well as implementational considerations like my different material types that I might need or structure specifications. For example, this is just an example of the database structure specification, and they're specified almost like a recipe. What are their attributes? What are they made of? And the database can give you a number of different fill volumes, number of posts I need for a specific structure type. And one of the nice things about the database is that it can actually export these almost structure recipe playing cards with structure dimensions, post spacing, number of posts I'll need, and then materials that I might need if I need to make a material list or move materials in, and then also structure, function, or construction considerations. So you can hand this right to maybe an implementation crew, and when they see that it's a primary BDA, they know that they need to kind of build this and have these materials on hand. So that's just an example of specifying a structure and exporting. So that's some of how the protocol handles design and implementation, a very small part of it. Let's look a little bit and talk about the monitoring protocols built into the protocol. So I wanted to differentiate the monitoring protocols from the design and implementation based on the kind of target user. So the target users for the design and implementation components are really things like project managers, restoration designers, construction foremen. While for monitoring surveys, we wanted these to be accessible to really anybody that has a basic term, understands basic fluvial terminology and taxonomy, so that you can hire a summer research technician or a volunteer and they can go out and conduct some of this monitoring. They don't have to have a very kind of comprehensive understanding of each reach, each complex, and the objectives or design associated with those things. They can just conduct the survey. Okay, so that being said, the protocol does contain 3 monitoring survey types. So the rapid monitoring visit, field survey of geomorphic units and structures, and then also remote riverscape surveys. So let's just talk a little bit about these quickly. First, the concept of the rapid monitoring visit. So in many cases, monitoring dollars just aren't there, and this is maybe the extent of monitoring that's going to be possible, an opportunistic field visit to check in on your project. This is really common. But we have developed a small monitoring visit protocol that just allows you to collect a couple small pieces of information, such as what percentage of my recovery potential, the width of my valley bottom have I achieved according to what I specified and during my planning. Am I making progress towards the specifications of my objectives? So really, it's almost limited to just those simple pieces of information, along with some notes about what I've seen, but just allows you to really kind of leverage opportunistic visits for some fast, cheap monitoring that can also be somewhat effective over time. Okay, kind of in contrast to that is the more involved field surveys. So the field surveys, consists of a structure survey, which is a survey of your beaver dams and woody debris jams, both natural and artificial, their locations, their function, their condition, so all their different characteristics, so that how many structures do I still have on the landscape, what has happened to them, Do I have natural structures now beginning to occur within my project area? So tracking the actual structural components within your restoration area. The field survey also consists of a geomorphic unit survey. So this is in-channel geomorphic units. So things like your pools, your bars, your ponds, and your glides, rapids, and runs. The geomorphic unit dimensions, their locations, and characteristics. So this survey is designed to still be rapid and give you a number of metrics related to and describing things like channel complexity, aquatic habitat capacity. So that's the field surveys, the structure survey and the geomorphic unit survey, designed to be done on the ground using the iPad. So last little protocol built into, survey built into the protocol is being referred to as the remote riverscape survey. So this is a protocol designed to consistently quantify riverscape features based on ortho imagery. So this could be imagery that you capture with a drone, or it could be imagery that's free and readily available. So designed to capture things like what's my primary and non-primary channel lengths, how are my active channel and active floodplain changing over time, and what's my riparian vegetation composition and extent. So a number of metrics kind of describing these larger riverscape features from aerial imagery. Okay, so the last thing I want to quickly mention is that these survey protocols have really been designed to generate a number of metrics that can be linked directly to objectives. So for example, this table describes indicators of in-channel habitat quantity and quality. It gives you a number of metrics, which survey those metrics can be generated from, and a small interpretation that links those metrics directly to objectives. The idea here is that when you're doing your project planning or seeking implementation funding, it's very easy to say, yes, I do have project objectives, and yes, I do know how I'm going to quantify them and what monitoring methods I can use in the field. So we've made a real effort to do this within the protocols. Okay, lastly, let's just cover a few protocol resources. First, all of the things I covered today, the protocol, the database, and a bunch of learning resources, about 2 hours to get you up and running, are all available on a website at fmltpbr.riverscapes.xyz. We also, to support information sharing, have a LTPBR Explorer website that's operational. It's just a simple website that stores basic project information, location, number of structures, length, goals, and objectives. So far, the website documents something like 45 projects, 3,157 structures, and about 103 kilometers of restoration. And while that's impressive, we know that a lot of the people that are a part of this workshop have a lot of projects of their own and are planning a lot of projects of their own. And so it would be very cool to see the map documenting project locations go from its current state to something like this. So I'd love to see people get on this website and just enter basic project information so that we can all kind of just share and see the real extent that LTPBR is being implemented. Okay, lastly, I just want to add a little caveat to these tools that we really kind of see currently that this protocol is kind of a draft, and that the data management and capture solutions are also kind of a draft. We expect these things to change over time. They definitely have been released right now as something like an operational grade that's very usable. I use this for my project planning and documentation. But we expect it to change with feedback from users and as we kind of throw rocks at and put these kind of tools through their paces. And so, I'll absolutely use these, and we'd love to hear feedback on what would work for you. Okay, all. Thanks a lot for joining me to talk a little bit about field design documentation approaches, and thanks again.